This is part 3 of the review guide. Like I said, with the first couple parts, you can purchase this on teacherspayteachers.com if you're just watching it and you're not in my class. So we're going to look at, for this, we're going to look at going from similarity proofs down to law of sine. So we're going to look at 9, 10, 11, and 12 in this review video. So you can go ahead right now and turn to page 21. So on page 21, it talks about similarity proofs. We have the 3 different proof methods: side, 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 angle, angle. We'll look at a proof, and we'll also discuss if we have similar figures based on transformations. So we'll be talking about dilations and then the other 3 rigid motions. So with question 1, you got a pair of triangles that are similar, kind of like we talked about in part 1 with congruent triangles. The name is everything. So for example, if you're talking about part A, angle G would be the same as angle L, because both of those are the 3rd letter. So when you go through and label each answer, just make sure you use that knowledge. Go into question 2. Below, we're going to look at A. So they want to know if the triangle BCD is similar to triangle MEH. And for this to be true, we're going to have some sort of dilation and maybe some other figure. So each of these, you can tell if the sizes are different. So what you want to try to figure out is take a point. So you take the point B. B should be similar to M based on the name, and see if there is some consistent scale factor that allows you to get from B to M. So for this case, for A, if you go up 3 and over 1, you get to B, and if you go up 6 and over 2, you get to M. So that means to get from 3, 1 to 6, 2, that would be a dilation of 2. Then you want to check another point just to make sure. So like if I went from A to D, we have 3 spaces, and then the H would be another 3. So in this case, this would be a yes, and then we have a dilation with a scale factor of 2. And with the other ones, you may have to use a rotation, translation, reflection. That's fine, but a dilation does need to be involved in each of the questions dealing with similarity. Now we're going to look at a similarity proof. So if you look at 6, prove that the 2 triangles have 2 congruent corresponding angles and they must be similar. So like in this case right here, they gave us 2 of the angles. Now in this case, angle B is congruent to angle K, and angle C is congruent to angle L. So we're trying to prove the triangles. So we know from this information that these triangles are similar because of angle, angle. So we talked about those briefly on the front. Now if you do use SAS and SSS, you do have to make sure you have a proportion. But in this case, this is angle, angle because, well, there's 2 angles marked. So if you do see, like with B, you do see sides, then you want to make sure you set up a proportion and use the cross product. So the proportion should equal when you use that. So we're going to move on to the next section, which is going to talk about sine, cosine, and tangent. You'll definitely need a calculator handy for it. So if you go to page number, I believe it's page 24. So up at the top, I put the 3 different ratios for sine, cosine, and tangent, what sides you need. One of the big things is if you need to find the angle measure, use the inverse. So you just make sure you use sine, the inverse sine, or the inverse cosine, or inverse tangent. And I know I spend a lot of time with my students on this, and they still struggled, but you want to make sure first that you label the pictures. So first thing you want to do is label the hypotenuse. So I'm going to do that with question 1. Hypotenuse is across from the right angle. I have a reference angle in the question as 28 degrees. So the side opposite that would be 18. And then the adjacent side is next to that reference angle. So I'm going to set this up by first looking at the 3 up the top and seeing which 2 sides I have marked. So I have O and H. So that means I'm going to have to do sine of the angle equals O, 18 over H, which is X. For this one, I'm going to cross multiply. And you can have X on the right side as the top or bottom. But when I do cross multiply this, I got 18 times 1, which is 18. And then I have the sine of 28 times X. So to get X by itself, I'm going to divide by the sine of 28. So what's going to go in your calculator would be this. 18 divided by the sine of 28. Also, when you use your calculator, I'm going to pull this up right now. After you turn it on, go to mode. Make sure you're in degree mode for each of the questions that you're solving. That way you don't get an incorrect answer. Okay. So I'll type that one in. We got 18 divided by the sine of 28. And we got 38.3 for X. So we got 38.34, which would then be answer D for this question. Okay. And again, think about if your answer makes sense. We're looking for the hypotenuse. It should be bigger than the leg that we have, which in this case was 18. So on the next page, 25, we're going to look at question 8. So we got a picture, we got a label. Tommy has caught his kite at the top of a 16-foot tree. So they're saying the tree is 16 feet. Where Tommy stands, they have an angle of elevation of 29 degrees. And they want to know what the length of the string is. So the string is going to be connecting. Okay, so you want to make sure you focus on labeling, label the numbers, and then go through and label the types of sides. So again, we got hypotenuse, opposite, adjacent. So we're going to have to use sine again for this one. So that's one of the big things you want to focus on. I'm not going to solve this one right now, but again, something you want to think about. Now we're going to go to the SineCosine Relationship page. And the big idea here is because we have a right triangle, and there's 180 degrees total, you want to make sure that the sine and cosine values depend on where the reference angle is located. So if I said this was a 40-degree angle, then this remaining angle would have to be 50 degrees. So they're asking which statement is false. So if I use my calculator and I check answer B, if I do sine of 70, that's going to equal a decimal. And then if I did the cosine of 20, that's going to equal the same decimal, because the 70-degree angle and the 20-degree angle would make up that other 2 angles of the right triangle. So you're trying to figure out, in this case, which one of these is false. Now, they're asking for the ratio of 12 to 13, which the found is not equal to this value. So what you want to do is go through and try to figure out which one isn't. So like if I was trying to do, let's say, answer B, cosine of C. Well, I know cosine is adjacent over hypotenuse. So I would go to my angle of C. Based on that angle, I have the hypotenuse, opposite, and adjacent. And based on the letters I marked it, I have A and H. So that one is equal to 12 over 13, so I can cross that out because we want which one is not. And then moving on to the bottom, when you're trying to solve the bottom, again, those 2 measurements for sine and cosine, the numbers themselves, the degrees, should be complementary, so they should add up to equal 90. So for example, for A, it'd just be 27 plus what equals 90. But if you take a more complicated one like H, again, it'd be 3x plus 25 plus 2x plus 10 equals 90 degrees, and you have to solve for x. And you can always check it by plugging it back in the calculator. So that will help with the sine-cosine relationship, which they usually throw a question on the Regents about. And then the last part we're going to talk about is law of sines, which I know we didn't really spend too much time on in class. But with law of sines, to solve the law of sines, you need to have two of the angles and one of the opposite sides. So if you look at, let's say, question 1, the law of sines can be used to solve triangle ABC. So what you would do is just draw a triangle, label it ABC, and then label the values. So angle A is 48, B is 74, and then C is 13. So the little c denotes a side, and then these are both obviously angles. Now we could use law of sines for this because we can figure out this other angle. So 48 and 74 is going to be 122, and that means this is 58. So we could use those three angles to help us find either A or B instead of proportions. So this one will be true in that case. Now let's actually go on to the next page and solve one. Show you how to set it up and solve it. So if you go to 6, and we'll look at A, and we're going to actually solve how to find and solve what A is for this at side length. Now the first thing I'm going to do is I'm going to figure out angle C. So we got 51 and 104, which is 155. So angle C is going to be 25. Okay, I'll throw that in there. Next thing we're going to do is find side A. And again, it's just a proportion. So I'm going to have to use an angle inside and an angle. Now we have a missing side. So I'm going to do, in this case, sine of A over A, sine of B over B. So sine of A will be sine of 51 over A, which would equal sine of 104 over 12. So what I'll have to do with my calculator right now, first thing I'm going to do is show you how to cross multiply it. And I'll have to write it up above B because I'm running out of space, but we got sine of 51 times 12, and that's going to equal sine of 104 times A. So to figure out the answer, to get A by itself, I'm going to have to divide by the sine of 104. So what that means is in my calculator, I'll have to finish this problem by taking the sine of 51, multiplying it by 12, hit enter, and then I will divide it by the sine of 104, which ends up being 9.61. Let's see if it says to round it. It doesn't give us anything specific here, but I will put it to the nearest tenth. I'll do 9.6 for A. So that ends up being 9.6, which means in turn C, because it's the smallest angle, this right here should be less than 9.6. So C's got to be less than 9.6 because the bigger the angle, or the smaller the angle in this case, the smaller the length of the side, as you can kind of see. Okay. So good luck with part 3, and if you're in class right now and need help, please raise your hand and call me over.